In the last couple videos, which ironically are the first few videos in calculus, we talked a lot about slope. So I'm just going to do a quick recap here. We said slope used to be used as an m. And then we remembered that meant the change in y over the change in x. It's a ratio between height and width of whatever line you're looking at, right? Here's your delta x, here's your delta y. And we would say, this is 5 divided by 5. So my slope is 1. And it tells you which direction the line points. If you're pointing down, maybe this is like a -1/2. Down this way is more like -50. And up this way could be even infinity if it's straight up, but it's always in this range here. If you remember that, you're off to a good start. And we expanded on that by saying, well, the change in y would be the second y minus the first y. That's how far we traveled. And same for the x's. And then we remembered, of course, that when you write y equals mx plus b, the y value is actually determined by the x value, so it's not really fair to call it a y because we want to indicate that. We want to say the function of x2 minus the function of x1. Those are our y values. You use the x's in the inputs, and you get some kind of output that we used to call the y values, divided by x2 minus x1. And then I took it even a step farther with us. I said if we have a couple points here, and we want this distance, that's x2 minus x1, and this distance is y2 minus y1. Well, if we don't want to call them x1 and y1 anymore, let's label these points instead as x and y, which is the f of x value. And then as you travel h distance, then this is an x plus h for the x value. And the y value is that as its input, so f of x plus h. And we can use that information to rewrite on top, where you get f of x plus h minus f of x over x plus h instead of x2 minus x. And then when these cancel on bottom, you're only going to have h remaining. So this became our definition of derivative, and we use that to play with parabolas and stuff. I want you to keep this in mind because we're going to be going forward with that understanding, okay? Now, if I want to talk about limits, this isn't like a speed limit where it's something you try to hit or something that you might even be able to go over. It's something that you're approaching. You're going to hear that term a lot, approaching. So let's say I have a parabola here, and I want to draw a line on that parabola like this. And we'll make it red, why not? I'm going to put 2 points here, like this. And I want to calculate the slope here. Let's say this is a slope of 1. I'll just make a little table over here, slope of 1. And my next line, my real goal, let's talk about the goal. My goal is to find this slope here. At this point, I'm pointing in this upward direction. And the best way to do that is to take a guesstimate. So I'm picking 2 points on the parabola, and I'm going to say, okay, well, I ended up with this, which isn't exactly this, but maybe it's a good enough estimate for our purposes. And if you need something better, well, then you need to travel along the parabola a little ways, and maybe we're here, like this. So if I want to take a line now like this, it should be the case, let's say that maybe this is a 2. I'm just picking a number here. It's not that important. For the slope as we calculate it. The reason that we're going to go through this process, maybe we'll do gold next here, is that if you're doing this correctly, you want to bring the first and second points closer together. This guy and this guy were kind of far apart, right? And so is this guy, right? And so is our third guy, but they are getting closer. This guy has a slope of maybe more like 4. And as we move up the chain, and I'm going to start using regular pen now, if I keep moving points closer and closer and closer here, what you're going to find, and I'm going to zoom in on just these 2. Okay, so I'll just do like a dark point here, and I'm going to do like a gold point here, just to kind of look kind of like that. As you get close, this parabola looks almost like a straight line as it goes this direction. And you want to find this slope here at this point. Well, now this h distance here that we talked about before is like 0.01. It's very close. Compared to this h distance is more like 10. Well, that might not be close enough. This is 1,000 times closer. So it should be much more accurate. And we might find that the slope here is 5, 6, 6.5, 6.6, 6.8, and eventually maybe the correct answer would be 7 if we were able to. But if I keep bringing points closer and closer together here, eventually this gap becomes 0. And that is a problem, because as we look at the definition of derivative, as we're trying to find slope like that, we're going to get a divide by 0 here. And on top, these would be the same values. So you would get a 0 divided by 0, and that is no good in math. That's called an indeterminate. It's not 0, it's not infinity, it is an informationless number. 5 has information. It's 5. You know how much 5 is. 0 divided by 0 is meaningless. So a limit is intended to describe what it should be when you end up dividing by 0. By trying to circumvent it. You ever hear that phrase about jumping around something or jumping under something to get past it? So if I take these 2 points here, and we're going to pretend that they're going to get infinitely close together, and I'll call this point A, I'm going to call this x value of A and this x value of B. The way we write it as we try and squeeze these points together is the limit as A approaches B. Because really we know it's going to be as 5 approaches 5, right? But at first it's 4.9999 infinity 999 approaches 5. We will end up with some y value, and I'm going to make something up here. Let's say it's like 10.00003 minus 10.000 divided by this ridiculously small number on the bottom, like 0.0001, and you're going to end up with some number. It's like 6.999, and you know this is close to 7. You know the answer is probably supposed to be 7. But because you have to have something to divide by that's not 0, and you have to have something on top that's not 0, we have to come up with a way to describe what the number should be when you end up doing the 0 divided by 0. And that's what limit is really intended to accomplish. We call it the limit because there are a lot of times when you can't do that. I'll give you like a little visual example. Remember, we're not really going into the mathematics of it as so much as the concept here. So let's say that I have a graph like this, and it has an open hole here. It doesn't exist here. Okay, but if I'm able to read the formula and see that it's going right here, and I look on the other side and I see this going right here, I know what it's supposed to be. So even if I end up with like a 0 divided by 0 here, I know that it's supposed to be what this is here. That's what limits are to describe and what they're about. So don't let the notation of all this, like where they write it in cursive and as A approaches 0 and all that kind of stuff, just focus on understanding that it's like saying y equals. What is the real equals answer if it wasn't some messed up thing? And if you look at the graph, it'll be very clear to you that this should be right here if it was to follow the rules of the entire rest of the system. That's all a limit is to describe what that value would be if it wasn't what it is.